Hi everyone, welcome to my channel. I'm your instructor for today. With the subject PPD, which is power plant diesel, for the discussion of week 10 video discussion. So we will discuss the types, classification, functions, and characteristics of governor. We will describe a simple governor, types of governor, speed, and governor principle, and others. We will discuss also the types of classification and characteristics of governor. We will discuss the function of governor, such as measuring the speed and changing the engine fuel control. So let's get started. What is engine governor? A governor or speed limiter is a device used to measure and regulate the speed of a machine such as engine. So this is a simple type of governor. So in a hydraulic governor, there is flyweight inside. So looks like the principle of these two balls. Later on, you can see this what we call the flyweight inside the governor. So let's proceed. Function of engine governor: to maintain the engine speed at the desired value by controlling the fuel injection. So this is your simplified diagram of diesel engine governor. So you have here drive from engine. So this is drive from engine. This shaft is connected to the gear of the engine. Here the parts, the rotating shaft, this one, horizontal movement of weights, this one. So rotating weights or flyweight, vertical movement of a collar. So let us proceed. Purpose of governor: to automatically maintain the uniform speed of the engine within the specified limits whenever there is a variation of the load, to regulate the fuel supply to the engine as per load requirements, to regulate the main speed of the engines. It works intermittently. Example, only there's changes within the load, so mathematically it can express as delta N, or the speed. So the speed 2 minus speed 1, or speed 1 minus speed 2. So we're not calculating. We have to discuss only the as stated earlier here. We have to discuss that one. So next, types of engine governor. We have centrifugal governor, pendulum type watt governor, loaded type governor, gravity control type governor, spring control type governor, inertia and flywheel governor. So we have here types of governor used on diesel engines is dependent upon the application required. The six basic types of governors are as follows. So mechanical, centrifugal flyweight style that relies on the set of rotating flyweights. So as you can see here, there is a flyweights. This one, flyweights. And a control spring used since the inception of the diesel engine to control speed. So we have also power assisted to servo-mechanical style that operates similar to the mechanical centrifugal flyweight but uses engine oil under pressure to move the operating linkage. So this is called hydraulic. So power assisted servo-mechanical style, that is hydraulic because it is uses engine oil under pressure. So next, so the basic 6 B6 types here is already here. Let's see, 1, 2, 3, 4, 5, 6. Now we have here the centrifugal governor. Is a specific type of governor with a feedback system that controls the speed of an engine by regulating the flow of fuel or working fluid so as to maintain near constant speed. It uses the principle of proportional control. So it's not working here, so I forgot. I think I have to stop first and continue later. I have to configure this one to make it working. So I have to stop first. So now let us continue. So as you can see here, this flyweight is rotating together with the shaft. So as this rotating slowly or fast, you see, rotating fast, it is closing or making a smaller opening of the flaps here inside. So if this is this flyweight is rotating in low speed, it will be open full the flap, so giving more fuel and air. So this is a centrifugal governor. So let us proceed. Now we have here centrifugal governor pendulum type, gravity controlled and spring controlled. This type of governor has a mass known as a governor ball that rotates at a distance from the axis. The governing action depends on the change of the speed and centrifugal force by the governor. So pendulum type, gravity controlled and spring controlled. So as you can see here, this is described in the centrifugal governor. Described here. So let us proceed here. Pendulum type, so it's also the same. So this is also centrifugal governor. So this is hydraulic governor. So most commonly used in marine diesel engine, especially the diesel generator. So this one. So hydraulic governor. Hydraulic governor that relies on the movement of the pilot valve plunger to control pressurized oil flow to a power piston, which in turn moves the fuel control mechanism. So later on we can see the control mechanism. So this one is connected to the fuel linkage. So there is also a flyweight here inside, just as you can see here. Flyweight. So here inside, and as you can see here, there is a servo motor. So this is connected to the what we call the main switchboard to engine control room. So this is the common governor, Woodward governor, and diesel generator. We have also here electronic governor. uses magnetic speed sensor to monitor the RPM of the engine. The sensor continuously feeds information back to the ECM, which is electronic control module. So I also experienced with this governor before. So this one also I always experience, and this one also I also experience this one. So as you can see here, there is no, this governor, there is no mechanical part. As you can see, this is electronic. So this is card, electronic card, and with the system components. So this will read the feedback. So feeds information or the feedback information from the sensor, which is magnetic speed sensor to your engine. So give signals here, and as you can see here, there is a diaphragm. So this giving what we call the air supply. So air supply. So actually this is it's either a combination of EP converter, electronic pneumatic converter. So the electronic signal is converted into pressure of the air, control air. So this one here is electronic. So this giving a signal to your what we call the because this is governor, this is controlling the speed of the engine. So I experienced this one before in Caterpillar engine. So I worked before in Caterpillar engine also. So I experienced this electronic governor. So later on we can see the schematic, what we call the mechanism, example of this governing system. Working principle of hydraulic governor. So here, working principle. So power is supplied to the governor from the engine's output shaft by a belt or chain connected to the lower belt. So this is for a small engine. Belt wheel. The governor is connected to throttle valve that regulates the flow of working fluid supplied to the prime mover, which is engine. As the speed of the prime mover increases, the central spindle of the governor rotates at a faster rate, and the kinetic energy of the balls increases. This allows the two masses on lever arms to move outwards and upwards against the gravity. If the motion goes far enough, this motion causes the lever arms to fall down on the thrust bearing, which moves a beam linkage, which reduces the aperture of the throttle valve. The rate of working fluid entering in the cylinder is thus reduced, and speed of the prime mover is controlled, preventing overspeeding. So as we can see here, this description, it is described here. So there is a connection here to the engine. So there is a shaft, and if this your engine is turning fast, this shaft also here inside is turning fast and turning past the flyweight. This one. So remember, if this is turning past the flyweight, the fuel is reduced. If this is turning slow, the fuel is meaning the engine is turning slow. There is a need of more fuel to become to rotate fast, to speed. But if this is already fast RPM, it will reduce also the fuel. That's why as you can see here, it will almost close the fuel. So now we will continue. The basic principle of hydraulic governor is very simple. When the governor is operating at control speed or state of a balance, the pilot valve closes the port and there is no oil flow. When the governor speed falls due to the increase in engine load, so the flyweights move inward and the pilot valve moves down. So as we can see here, see, This is your governor. So more oil to push this piston will increase the fuel. You see? Increase the fuel. So more oil. So this is a signal, load signal. So solenoid. So to hydraulic pilot valve. So from load sensing servo piston, center spring. So fuel rack servo position. So more oil to push the piston will increase the fuel. Next. So this is the example. Speed governor installed on 4-stroke diesel engine. So as you can see here, this is a load. This is either alternator or pumps or etc. But this is a load. So there is what we call the magnetic pickup or magnetic sensor. As you can see here in the flywheel. So it's giving signal to the governor and giving more fuel. Here, this is your fuel rack, fuel linkage, and this is your fuel rack. So giving more fuel if the engine is still low speed, and if the engine is up to the desired RPM, so it will maintain. So I have the fuel rack, air intake here, intake manifold, the piston, so exhaust. So this is your governing system. Types of governor for engines used on ships. So a governor is a system that uses to maintain the main speed of an engine with certain limits. Under black-weighting load conditions, it does this by regulating and controlling the amount of fuel supplied to the engine. So remember, keyword, regulating and controlling the amount of fuel supplied to the engine. So that is the function of governor. So the governor limits the speed to the engine when it's running at the no load condition. Example, it governs the idle speed and ensures that the engine speed does not exceed the maximum value as specified by manufacturers or maker. All marine vessels need a speed control system to control and govern the speed of the propulsion plant being used on board, as there can be a large number of variations that arise on engine load, which may damage the engine and causes loss of life and equipment. The variation in the load on the engine may arise due to several factors such as ruptures, rolling and pitching of the vessel, compromise, ship structure, changes in the weight of the ship, among others. So governors also fitted in the auxiliary diesel engines or the generators and alternators on the ship. So you have to here's this one. So classification of governors on the basis of design and construction. Mechanical governors. These governors consist of weighted balls or flyweights. So weighted balls or flyweights the same. That the same function. So that experience a centrifugal force. So centrifugal force. When rotating by the action of the engine crankshaft, this centrifugal force acts as the controlling force and is used to regulate fuel supplied to the engine by a throttling mechanism connected directly to the injection racks. This weight assemblies are small and hence the force generated is not enough to control the injection pumps of large engines. They can be used where exact speed control is not required. They have a large deadband and have small power output. So we have here the advantages. They are cheap. They can be used when it is not necessary to maintain an exact speed depending on the load. They are simple in construction and have only one few parts. So we have here the what we call the so we have here the flyweights. So you can see this one inside the governor. So I show you a while ago the hydraulic governor, so you can see this one. So I already dismantled this many times. So we have the spindle. So this spindle is connected to the gear of the as you can see here, the rotating engine. So this is connected, and the rotating engine is turning fast. This flyweight is rotating slow and reduce the fuel. If this one is rotating slow, this drive, and this if this flyweight is rotating fast, that means it will reduce the fuel. And if this flyweight is, if this drive is rotating slow and this flyweight rotating slow, it will add more fuel. So let us proceed. Hydraulic governors. In hydraulic governors are with the assembly is connected to control valve rather than the fuel control racks directly as the case in the mechanical governor. This valve is responsible for directing hydraulic fluid which controls the fuel racks and hence the power or speed of an engine. A greater force can generated, and these governors find application in medium to large size engines. These days most ships use hydraulic governors and are being retrofitted with electronic controls. So we have also here advantages and disadvantages of hydraulic governor. So they have a high, so advantages, they have a high power output, they have a high accuracy and precision. So here, they have a high efficiency and maintenance of hydraulic governors is easy. So this is oil inlet, oil outlet. So this is the flyweight, the conical spring, and for increasing fuel, this one. So let's proceed. We have also what we call the electro-hydraulic governors. These kinds of governors have an actuator with two sections of a mechanical hydraulic backup and electric governor. In case of failure of the electric governor, the unit can be in manual control. On the mechanical hydraulic backup governor, the mechanical governor is set at speed which is higher than the rated speed. The speed and the load of the entire systems are controlled by electronic governor. So the system has an electronic control valve that is connected to the armature and the electromagnetic field. So an ECB, electronic control box, sends signal to the field which position of armature, and hence the control valve that regulates fuel delivery, the electronic control overrides the mechanical hydraulic mode when the system is set on the electronic operation. So we have here the advantages of electronic governors. Faster response to load changes, control functions can easily be built in the governors. Presence of indicators and controls have implemented automation. So they can be mounted in position remote from the engine and eliminate or reduce the need of the governor drives. So we have the classification of governors on the basis of their operating principles. So we have a flyweight assembly. we have also flyweight assembly. So almost all types of governors are fitted with a flyweight assembly. 2 or 4 flyweights are mounted on a rotating ball head that is driven directly by the engine shaft. So as I show here, so this is the drive of this governor spindle. Using a gear drive assembly, the rotation of the ball heads creates a centrifugal force that acts on the flyweights of the assembly and causes them to move outward. Centrifugal force. So move outward. So away from their axis of rotation as the speed of rotation is increased and the degree of outward movement of the flyweights also increases, and vice versa. And hence the movement of the flyweights depends on the engine speed. So a spring is installed to counteract the centrifugal force generated on the flyweights and forces them towards their initial position. So this spring is known as the speeder. Spring, the position of the flyweights under outward movement is transmitted to the spindle. So this may be done through a cooler which is free to move as a reciprocating fashion. The movement of the spindle which forms the control sleeves actuates a linkage to the fuel pump control and ultimately controls the amount of fuel injected. So as you can see here, we will go back first to the example here. So as you can see here, so I read the statement. So this is the movement of the flyweights and controlling the flaps, you see. So slow turn, high turn will almost close the flaps, and slow turn will fully open the flap to supply fuel and air. So we will come back here. So this one on speed. So as you can see, the movement of the flyweight in this position on speed, so meaning on a rated speed. But here when the flyweight is going like this, you see, so this is low rotation, so it will high rotation, then this is already overspeed. When the flyweight is going like this inside, so this outside is overspeed, and the flyweight is going inside, you see, this is underspeed. So this one spindle is connected to the drive of your engine to rotate this, to operate this governor. So let us proceed. Under normal operating circumstances, example, constant speed and loads, the control sleeve remains stationary. So meaning steady. So as the force on the flyweights is balanced by the counteracting force exerted by the speeder spring. So as the load on the engine is increased, the speed of the engine reduces and the control sleeve moves downward. As the force exerted on it by speeder spring becomes the force exerted by the flyweights. So then downward movements of the sleeve is linked to the fuel control rack, such as there is an increase the fuel delivery and thus the power generated by the engine. The force on the flyweight increases with the engine RPM, and once again the system comes back to equilibrium. So as the load on the engine is decreased, it increases, the flyweights move outward, and in turn the control sleeve moves upward as the centrifugal force overcomes the speeder spring force. The movement of the sleeve actuates the fuel pump. Fuel delivery is lowered, thus speed of the engine is reduced and the system becomes equilibrium. So as you can see here, this position of the flyweight is on speed or on the rated speed, and this one, the position of the flyweights is in overspeed here, and this one is outside, and if the position of flyweights is inside, this is under speed. So we have here also the hydraulic control. In this case, the flyweights are linked to the hydraulically to the fuel control assembly. This system consists of a pilot control valve which connected to the governor spindle and the piston. So this piston is known as the power piston and controls the amount of fuel delivered to the engine. It is acted upon by force of the spring and the hydraulic fluid on the opposite sides. So later on we can see the diagram. So the amount of oil in the system and subsequently the hydraulic pressure on the piston is regulated by the pilot valve that is ultimately controlled by the flyweight assembly. The control valve sleeve is open to the bottom where an oil sum is present in the lower side of the governor housing. So a gear pump which supplies high pressure hydraulic oil to the system takes suction. So from the sump, it is driven by the governor drive shaft. Spring loaded accumulator is present which maintains the required pressure head of oil and allows the drainage of excess oil back to the sump. So where is this drawing? So a lot of information here. So in case of constant speed, a load operation, the valve is positioned to block the ports in the valve sleeve and hence the passage of an oil to the power pistons which remains stationary under balance forces. So an increase in the load decreases engine speed. In this case, the flyweight moves inwards. So as I mentioned earlier. So and that governor spindle moves downward and the action of the force of the speeder spring. So this movement lowers the pilot control valve which directs oil to the underside of the piston, power piston. So as the hydraulic pressure on the piston overcomes the spring force acting on it, the piston moves downward and the fuel supply to the system engine is increased. Hence, increasing its speed once the RPM of the engine increases, the control valve rises to its initial position that blocks delivery of the hydraulic fluid to the power piston. So later on we will see the drawing. So on the other hand, as the load on the engine is decreased and its speed increases the outward movement of the flyweights. So I said earlier, outward movement of flyweights is under the action of additional centrifugal force causes subsequent upward movement of the spindle and hence the pilot control valve rises as well. So this opens the port such that hydraulic oil in the system flows to the oil sump from under the power piston through a drainage passage. So the power piston then moves downwards under the action of the spring force and reduce the hydraulic pressure and hence reduce the amount of the supplied to the engine is decreased. This reduces the engine speed and so a lot of the information. Consequently, the forces on the flyweights are balanced once again. So governor sensitivity to increase the sensitivity of the governor and to prevent overcorrection of the system. A compensating mechanism is incorporated to the governor design in case of the hydraulic governor plunger is present on the power piston shaft and on the drive shaft. These are known as rotating compensation plunger and the receiving compensation plunger respectively. The compensating plunger moves in the cylinder which is of hydraulic fluid. So this plunger moves in the same direction as the piston, power piston. The downward movement of The power piston is due to an increase in engine speed as moves the compensating plunger downwards. So due to this, the plunger draws oil from the hydraulic present below the pilot valve bushing. So this creates suction above the receiving compensating plunger, which is a part of the bushing. The bushing moves downwards and closes the port of the piston. So we have here the Woodward governor, so fitted on the engine. So it is not really clear, but this is the Woodward governor. So we have here now there's a lot of information in this topic. So that's the pilot valve port is open just long enough so that for the engine speed to return to the set rate and avoiding overcorrection, as the flyweights and the pilot valve return to their central position, oil flowing to the needle valve allows the pilot valve bushing to also reach its central position. So the bushing and plunger must descend at the same speed and keep the port closed. So the needle valves must be adjusted carefully to allow the correct amount of oil to pass through it. So this depends upon the engine requirements according to the manufacturer. In case of the decrease in the engine speed, the actuating compensating plunger moves upwards and the pressure on the receiving compensating plunger is increased. It moves up the pilot valve bushing. So the port leading to the power cylinder remains closed and the excess oil is drained out through the needle valve and the bushing is then returned to its central position. So where is this drawing? So the drawing here, here is the drawing. So this one. So inlet of oil. So we have also here the electronic system. An electronic governor provides an engine adjustment from no load condition to full load. It consists of controller, an electromagnetic pickup, MPO, and the actuator, ACT, to carry out the necessary speed control and regulation. So the MPO is a micro generator and has a magnetic field. It consists of a permanent magnet with an external coil winding. So as shown in figure diagram, the MPO is, so later on here you can see. So MPO is installed above the flywheel teeth and depending upon its distance from the gear teeth or slot, and the magnetic field of the MPO varies from a maximum to maintain respectively due to the constantly changing internal magnetic field, and AC voltage and frequency is generated in the outer conducting coil. So this AC voltage follows the speed of the flywheel. So this is the most important aspect of the electronic control system, as the governor controller converts the obtained frequency into DC voltage signal. So it then compares this with a set voltage. So the results are calculated by a PID control. So proportional integral differential PID control. So this controller is a feedback system. So and finally, the output reaches the actuator, which implements the required corrections on the fuel supply to the engine. So we have here electronic controller has different modes of operation. So implement various functions. So this includes detecting and starting of an engine and subsequently directing the fuel supply. So suppressing the smoke generated by the engine as its speed increases. Adjusting a drop percentage. So a detailed explanation of the drop percentage is given below. Remote speed control, ideal speed operation. It provides speed control over the entire torque capacity of the engine. So we have here maximum speed control. It is used to eliminate over speeding of the engine. So as you can see here, this is your flywheel and this is your engine. So this is your engine. This is the load. This is generator. So in the flywheel, you have what we call the magnetic pickup unit, MPU, or the sensor. The magnetic pickup unit or sensor, this one here. So as this flywheel is rotating, so it sends sensor is working. So it sends signals to the governor controller. So the governor controller also sends signal to the actuator. So the actuator will move the fuel valve rack, and so this is your fuel inlet of your fuel. So this actuator moving the fuel rack give fuel in the fuel valve here to the engine. So this is the system of the governing system. So it's still a lot. So we have also maintenance of governors. So governors should always be kept clean, and it should be free of dirty lubricating oil. Regular flushing of the system with the right lubricating oil should be carried out. The hydraulic fluid and lubricating oil should be of the correct viscosity as mandated by the manufacturers should be used. So maker, the system oil level should be maintained and checked. But the governor is not to be tampered with, and the repairs and operation should be carried out only by experienced operator. So we have also here what is drop. So as the load on the engine increases, the fuel of the engine is increases, and yet it is allowed to run on a proportionally lower speed. This feature of a governing system is termed as drop. So when more than one prime movers as connected to the same shaft, so as in the case of generating electrical power, drop permits as stable division of load between them. So the prime mover, this prime mover is an engine, so can be run at a drop speed control mode, wherein it is running speed it set as percentage of the actual speed. As the load on the generator is increased from no load to full load, the actual speed of the engine prime mover tends to decrease to increase the power output. In this mode, the prime mover speed reference is increased, and hence the flow of working fluid fuel to the prime mover is increased. So it is measured as percentage according to the formula. So drop percent is equal to no load speed minus the full load speed divided by no load speed. So that is the formula of drop and percent. So what is the use of the speeder spring? The governed speed of the engine is set by changing the tension of the speed adjusting spring, which is also known as the speeder spring. So the tension of the spring counteracts the force exerted by the flywheel on the spindle. The pressure of the spring determines and the speed of the engines. So we have here, so speed of the engine that is necessary for the flyweights to maintain their central position. So what is deadband also? Deadband. So deadband of a governor gives the range of speed after which the governor starts operating to make corrective adjustments within this range. The governor does not operate at all. So the weight of the deadband is inversely proportional to the sensitivity of governor. So here also, what is hunting? So hunting is common. Example, your hunting, if there is air in the system, of the governor, so it will cause hunting also. So the continuous fluctuation of, so hunting is fluctuation. Hunting is fluctuation. Fluctuation of the engine speed around the mean required speed is known as hunting. So this happens when the governor is too sensitive and changes the fuel supply even with the small changes in the engine RPM. So it supplies either too much fuel or too less fuel, and governor slave repeatedly moves to its highest position. So this cycle continues infinitely and the engine is said to hunt. So this is your Woodward governor. So this is common use on, especially on the diesel generator engine. So this is Woodward governor, hydraulic governor. This is hydraulic governor. So this is the end of discussion. So please subscribe my channel. Please click share, click like, and click notification button. And thank you for watching. See you on my next video.